In this example, we are going to be calculating equilibrium concentrations. We have hydrogen iodide reacting to form hydrogen gas and iodine gas. If we have 0.1 moles of hydrogen iodide placed in a 1 liter container and allowed to reach equilibrium at this temperature, find the concentration of each substance at equilibrium. And here we're given our equilibrium constant, our KEQ. So the first thing that we're going to do is find the concentration of hydrogen iodide, since it gives us our mole and our liter amount, our volume. We have 0.100 moles divided by 1.00 liter, which gives me my 0.100 moles per liter. This one happened to be the same, but always double check because it can affect your whole answer if you have the wrong concentration. Next step, we are going to set up our ice table. So we have 2 hydrogen iodide reacting in equilibrium to make hydrogen gas and iodine gas. My initial concentration is 0.100 for hydrogen iodide. I have nothing yet of my products. There's a change that will occur, so I'm going to be minus 2x because I have that coefficient of 2. And here I'm going to have a positive x and a positive x. At equilibrium, I'm going to have 0.100 minus 2x, x, and x. I'm going to use this to set up here my equilibrium constant law. So here I know that I have my KEQ is equal to my products divided by my reactant raised to the power of 2. Again, we have that coefficient of 2. From the question, I have 1.84 times 10 to the negative 2 is equal to my x times x from these values right here. Okay, so we can just get rid of that now that we see where we're coming from. Then we have over 0.100 minus 2x. Okay, and this is squared. In my next step, I'm going to simplify further. And x times x becomes x squared. I still have this on the bottom. Now, if I want to get rid of my square, I can square root both sides. This will give me a value of 0.136 is equal to x over 0.100 minus 2x. My squares were canceled. Now, I'm going to bring this section over here up to the top. I'm going to multiply it on both sides. So I have 0.136 times 0.100 minus 2x is equal to x. And I'm going to keep solving so that I can get one value for x. So here we're going to have 0.0136 minus 0.271x. X has a value of 1. We can't see it, but that's there whenever you just have x by itself. So I'm going to bring all of my like terms to one side. So I'm going to keep 0.0136 over here. And I'm going to have 1x plus 0.271x. This will give me 0.0136 is equal to 1.271x. I'm going to divide both sides by 1.271. And my value for x is equal to 0.0107. Now that I have my x value, I'm going to, over here, find my equilibrium concentrations. So my hydrogen gas equilibrium concentration is my x value. So it is 0.0107 moles per liter. Same thing with my iodine gas. Now for my hydrogen iodide concentration, I need to put it into that original equation now that I have X. So here I'm going to have HI is equal to 0.100 minus 2 times 0.0107. When I simplify that, I'm going to get 0.0786 moles per liter. This was possible because I was given this value and I was able to solve for my X.